Hey everyone, welcome back to yet another AI Planet Expert Live session. Every one of us wants to learn machine learning and artificial intelligence. But the main part of AI and ML comes after you build your own algorithm. And the major thing is, okay, I guess it was repeating. The main part of building any AI ML application is how you can monitor, how you can scale, and how you can put this in a production. That's where we have multiple MLOps solution, and one of them is Kubeflow. Using Kubeflow, you can build your ML application where you can also integrate Kubernetes with it. Today, we have Suresh who will walk us through to Kubeflow on how we can get started with it. And to give you a short introduction about Suresh, he is a co-founder at InfoWaves and also is an organizer at GDG Sri Lanka. So without further ado, let's start with this session. Over to you, Suresh.
Thanks, Tarun. Hi everyone. As Tarun mentioned, I'm Suresh Peiris, and I'm the co-founder of Infowise, and also I'm a GDG Sri Lanka organizer. So a little bit of myself, I'm a cloud researcher, and also I'm an enthusiast on machine learning. So these days I do work on LLMs, and recently I worked on the most recent Google model, Gemma model. And that's a brief about myself. And yeah, so let's get started. So today, during the session, I'll be covering the basics of MLOps. So we'll be discussing what's MLOps and what the importance of MLOps and the importance of using MLOps in production scale. And also we'll be talking about Kubernetes, what's Kubernetes and the architecture of Kubernetes, right? And different places that we can use Kubernetes. So I'm sure that the most of the audience is on machine learning experts and developers. So I think this would give some kind of insight on what kind of deployment technologies we have in terms of cloud. So thirdly, we'll be discussing the architecture of Kubeflow and how we can deploy these Kubeflow clusters on Kubernetes and also in other cloud providers. So finally, we'll be doing a practical code lab example, which is given by Google. So these are the topics that we'll be mostly covering during today's session. Right, so to get things started, let me give you a very brief intro about what's MLOps. So in short form, we can call it as machine learning operations. It's like the behind the scenes magic that makes machine learning work smoothly. And also, we had to make sure that we create smarter models and we maintain this iteration process from design to model development to operations. So imagine it as a team effort involving computer wizards, data experts, and tech folks. So they work together to take our smart models and put them into action in real world. And once they're out there, we have to make sure that these models are performing at their best and it keeps improving and it keeps giving the correct outputs that we wanted. So basically, this is the workflow that we'll be addressing during the workflow of MLOps. So think of it as a conveyor belt that takes our smart models from lab to the production. So making sure that they are always in the best shape. So this will make sure that these models are giving us smart decisions, and also we have to keep improving these models. So yeah, so that's a very brief intro about MLOps. So basically, as you can see in the screen, these are the different stages that are involved when it comes to maintaining the pipelines of MLOps: the design stage, the model development stage, and the operation stage. So what happens is basically in the design stage, we choose the data sets, we choose the proper ML models and the architectures, right? So we plan what we are going to do next. And the right. So basically we work with the data and we work with the models on deciding what kind of model architecture that we plan. The second stage is going to be model development. So this is where most of the workbench is coming in, right? So we work with different types of IDs, different types of development techniques, and different types of frameworks, right? So this is where we develop the machine learning model. This is where all the frameworks are and the IDs are coming up. So in this stage, we work with the data. We gather the data that we have to. We work with the data that we have gathered from the previous step, and we start building the model. So sometimes this can be a complex process because we might have to work with different types of environments. Sometimes our machines might not be capable enough of handling large scale workloads. So we might get a requirement that we have to move it to the cloud when it comes to this model training. right? So that's where we have all of this stuff. And final stage, we have the operational stage. So when it comes to operational stage, we have to make sure after the deployment, after the development, we are supposed to deploy these machine learning models into the cloud environment, right? So this is where we have different types of technology such as CI/CD. So for an example, if we have teams working on different types of developments, it has to go simultaneously live in the production environments. So we have CI/CD pipelines, and also we have specially monitoring also. Because after development, after deployment, we can't just let the machine learning model handle it by its own, because we have to keep monitoring and we have to get statistics of the machine learning model to keep it improving. So for an example, let's say you're building a parameter tuning job, right? So in that case, we have to always keep monitoring the status of the machine learning model, the status of the accuracy levels. So this is where we have the operational stage where we monitor the status of the machine learning model and we keep improving this stuff. So this is not a iterative process, right? This keeps rotating multiple times, design, development, and the operations. So as you can see, it's a cyclic process that we continuously keep doing the same thing again and again. So this is called the machine learning MLOps life cycle. So this is very basic one that has been shared in the screen. So if I go to the next step, you can see that there are different steps involved, right? So in the first step, you can see the model preparation, data pipelines, model preparation, model deployment, DevOps, catalogs, and governance, right? So all of these stuff are involved when it comes to the machine learning operations lifecycle, from data model development to the end to the governance aspects. We have all of these operations. So when talking about the existing platforms that are there to manage all of this stuff, we know there's this platform called Google Vertex AI, one of the best platforms that you all can use to maintain the MLOps lifecycle, right? So in Vertex AI, they provide you all of these lifecycle management toolkits, mechanisms that you can use model development to the production itself. So when talking about Kubeflow, you might have a question: why are we going to switch to Kubeflow? Then since you already have Vertex AI, why do you need Kubeflow? So let's get into that topic as well. So until that, we'll discuss about other platforms that we also have. So Vertex AI has all of this stuff, and Kubeflow is also alternative. And let's talk about the main importance of Kubeflow as well. So both of these platforms are supporting the entire MLOps lifecycle from development to the end goal. So it helps us to keep this development lifecycle continuously up and running. So as you can see in the screen, these are the different steps and these are the different operations that we are doing to keep our machine learning models up and running all the time. Right. So let's talk about what's Kubernetes first. So I know most of you all might be from machine learning backgrounds, and most of you all might not have a background in terms of Kubernetes and cloud technologies. But let me give a very brief introduction. What's Kubernetes and Kubeflow? So Kubernetes can be known as a container orchestration platform. So for an example, let's say if you want to deploy your workload into production scale, we can use Kubernetes as a really good platform to deploy your production scale workloads, to scale up and down, to handle scaling and to handle different kind of microservices, right? So all of these architectures are supported in terms of Kubernetes. So for an example, let's say I have backend which is running locally, right? So I want to deploy that to production. So what I do is usually most of the people, they just get a standard instance such as compute instance or EC2 instance on AWS. They just deploy it over there. But there are different use cases that we have in terms of deploying these backends and these workloads on production environments. Especially, there's a real use case when it comes to the scaling, right? Because we know when we get a standalone instance, it's not going to scale up because it's a fixed resource allocated, right? So we might have to go for a scalable platform. So in terms of scaling, there are different types of platforms which are already there. For example, we have something called Google Cloud Run, and we have GK, the Google Kubernetes Engine. And also, if we go to AWS platforms, in AWS also we have different kind of container engines, and also we have some other alternatives also. If you go to Azure, we have something called App Service. So all of these platforms are there. But there are specific use cases that are required to deploy these workloads in cloud. So for an example, let's say if you want to monitor these workloads, if you want to see how these workloads are doing in cloud, sometimes we have like complex use cases, right? And we have to scale accordingly, up and down. So Kubernetes works as an all-in-one platform that handles scaling and that handles as a container orchestration platform. So it's pretty much scalable. It works with the native hardware resources, and it works with pretty much all the cloud providers which are already there. So there's a bit about Kubernetes. So Kubernetes as the main platform for Kubeflow. So Kubeflow is more like a user-managed machine learning platform that you can use to automate the entire machine learning workflow from development to deployment, right? So, like I mentioned, since Kubernetes is scalable and also it supports container orchestration, Kubeflow has been using Kubernetes to do the entire operations. It's built on top of Kubernetes resources. So let's talk more about it. So first of all, let's be familiarized with some of the basic concepts of Kubernetes, right? So we have something called Kubernetes clusters. So what's a cluster? So for an example, let's say if we have worked with these standalone instances on Google Compute Engine, or in Amazon EC2, you might know what these virtual machines are, right? So in Kubernetes clusters, basically it's like a collection of these virtual machines. This can be known as a collection of these virtual machines that works for a single purpose or multi-purpose. So in all of these cloud providers, they have their own Kubernetes engines. For example, on Google Cloud, they have this platform called GKE that works as a collection between that works as a managed Kubernetes provider. And in Amazon also we have the EKS service, the Elastic Kubernetes service, and in Azure also we have the AKS service. Right? So we have different types of Kubernetes providers, which are provided by these common cloud providers basically. So like I mentioned earlier, it's a set of worker machines. We can call it as nodes that runs on containers applications, right? So we know we have to make the environment that is required to run these machines. So basically, the environment is provided by the containerized applications. For an example, we had to Dockerize this application and deploy. So that's how these Kubernetes clusters are operating at the moment. And we have something called worker nodes in Kubernetes. So basically, worker nodes are responsible on executing these workloads. So these worker nodes can be as normal as these compute engine instances, but they are working for a purpose of processing all these Kubernetes workloads. So for an example, let's say if we have data processing job that needs to be handled, the end job will be handled through a virtual machine, which is offered by these cloud providers. If it's GCP, it works on compute engine. So basically, the scaling up and down and scaling of the pods will be done in terms of the virtual machines. And also, let me give you a very basic understanding about what the scaling is, right? So for an example, earlier I mentioned that we had something called compute engine. In compute engine standalone instances, if you deploy something on top of the compute engine instances, what happens is basically the resource will be fixed, right? It won't scale up and down. But if you want to handle scaling, we might have to group all these instances, and we might have to have a set of rules where we can scale up and down, either horizontally or vertically. So basically, these horizontal and vertical scaling rules can be set, but to manage it better, it requires some kind of a managed service. So Kubernetes is there to handle your scaling, to handle your scaling purposes, and also it will handle your deployment purposes and all of these monitoring purposes, and the traffic routing, in terms of traffic routing, scaling, deployment, and all of these stuff are handled from end to end using these Kubernetes clusters. And then to talk more about it, so let's talk why are we going to use this thing in Kubeflow. So as you can see in the screen, it says Kubeflow running on Kubernetes cluster provide data scientists and MLOps professionals a way to automate the execution, right? So like I mentioned earlier, there has to be some kind of a deployment mechanism where we deploy these workloads on cloud, and it has to scale accordingly. So if you take these Kubernetes clusters. Kubeflow is using Kubernetes as a main um, Kubeflow is using the Kubernetes as a main framework to deploy all of their workloads on cloud. So, right. So now let's talk about another concept in Kubernetes. So we have something called containers in Kubernetes. Right? So I'm sure if you are normal developers, right, I think all of you might have worked with VMs, or we can call it as virtual machines. For example, we have applications such as VirtualBox, VMware, right? So I think all of you have worked with these virtual machines if you have made applications. So usually these VMs are providing an isolated environment. For an example, if you want to run the secondary operating system, it provides you an isolated environment where you can run it as a secondary guest OS. But the main difference between a VM and a container is that in container is more like it provides an isolated environment with the configuration that you're providing. So I'll give a very basic example. So for an example, let's say you're developing an application that needs to be run on a particular, for an example, let's say you are developing an application that requires some kind of environment. For an example, if it's a machine learning application, that would require different kinds of libraries, frameworks, right? So all of this has to be locally set up in all the machines. Right? Let's say if you are building it your machine, if you want to ship it to a different person, the secondary person has to set up the entire environment, maybe setting up through Anaconda or Jupyter or any kind of environment provider. The person has to configure the entire environment, install packages and all of this stuff. So this can be a complex process, right? Because the entire environment, the exact same environment has to be populated. So it's a complex process. So basically, by having containers, we can isolate this environment and we can locally set up all of these libraries and frameworks, and we can isolate the environment and ship it to the next person. So by having a Docker container, we can easily, the secondary person can easily replicate the same environment that the first person is having. And in that way, without any issue, without any dependency issue, the second person can run the workload of the application very easy. So that's the concept of containers. So basically, these containers are being used throughout the Kubernetes platform that needs to be deployed. So all these workloads are being deployed as containers. So in that case, there won't be any kind of dependency issues because these are static containers, regardless of what your hardware boundaries are, right? So then the second point, the file system. So basically, the file system of containers, they share the CPU, right? Either we can allocate resources, or we can dedicate resources, or we can allocate memory. Right? All of this stuff can be done in the Kubernetes configurations. For an example, let's say we have workload container, and we can set whatever the hardware requirements that are required to run the particular workload in your machines. For an example, the CPU spaces, the memory spaces, and the process spaces. So all of these variable parameters can be set as the deployment parameters. And the third point, we have decoupled from the underlying infrastructure, right? So like I mentioned earlier, regardless of what your hardware boundaries are, you can set up your own containerized environment. So it isolates the interaction between the hardware properties, and regardless of what your operating system is, regardless of all of your system params, it will be an isolated environment where the containers can be run independently. And in that way, we can eliminate all of these hardware barriers, the software barriers as well. So in Kubeflow, we are using this isolated environment to deploy our machine learning containers and also to deploy our workloads seamlessly on cloud providers, right? So we'll talk about that, and we'll see that in action in the further demonstrations. So then we have another concept called pods in Kubernetes, right? So you all might be wondering what this KETS is basically. KETS is basically short form for Kubernetes. So I think I forgot to mention that in the earlier slide. So basically it's a short form for Kubernetes. And then let's talk about what's pods. So basically pods can be known as the smallest component of Kubernetes. Basically, for an example, let's say you deploy a workload. The workload would work as a pod there. So it can be identified as a pod. So the pod would have the container, right? So basically, the pod is basically a name. It's like a namespace given from Kubernetes. The pod could have a container which is running inside the pod, right? So for an example, let's say if it's a machine learning workload, we can have the Kubernetes engine provisions a pod, and the particular container would run under the pod, which is already defined by the Kubernetes. So we'll see what these pods are, and we'll see that in the demonstration. So then we have the second point. You can see a group of one or more containers with shared storage and network resources as a specific for how to run the containers. So in the pod, like I mentioned, we can allocate one or more containers. So basically, a pod is more like a group. It's a term that is being given from Kubernetes to group one or more containers, right? So for an example, if these containers are being used to um, use for a particular purpose, we can group all of this stuff using a pod, and it's more like it will be given a namespace. So from the namespace, we can identify what these containers are for and the purpose of these containers are within the Kubernetes platform. So in Kubeflow, these pods are simplifying the entire container management. So we can actually see the status of this container, the workloads also. So for an example, from the container creation to the deployment, we can always see what kind of a state that we are having in these pods. So the state management can be easily done with these concepts which we have in Kubernetes. The third concept, we have something called operators and controllers in Kubernetes. So in the default way, the Kubernetes resources are being deployed as either Helm charts or Ansible in Ansible frameworks. But if you want to automate the entire Kubernetes workflow, there's something called operators and controllers. Or we have something called custom resource definition. So we can call it as CRDs. So if we briefly talk about these operators, it's working with the Kubernetes API, and it will automate the entire deployment process. So for an example, let's say if you are deploying a web application, we have deployed several resources, right? We have deployed the deployment and services and ingress, or we can call it as the service, right? So all of this has to be manually deployed by defining the Kubernetes config, or we can call it as the ML config, or we can call it as Helm charts, right? So all of these resources has to be manually deployed, but there's a way of automating the entire process, right? So then we have something called operators and controllers. So from these operators, it does the entire deployment process. It automates the entire deployment process. So just by applying a YAML-based configuration, we can trigger these operators, and we can automate the entire deployment process of all of these resources in Kubernetes. So we have the operators and controllers that does the same purpose. So now for an example, in Kubeflow instance, we have something called training operator, and we have something called notebook controller, right? So, in Kubeflow, we can define different types of training jobs, right? That works within the cluster. So these stuff can be, so we have something called training operator in Kubeflow, right? So the moment we provision a training job, the training operator will catch the training job and it will execute the workload on top of the Kubernetes engine, right? So basically, this training operator is responsible on waiting for all the config applications, and it will trigger the training operator, and it will keep executing whenever the config is being applied. So for an example, you can see we have training operators for TensorFlow, PyTorch, and Apache, Apache MXNet, XGBoost, and all of these stuff are supported on top of Kubernetes. And then we have something called notebook control. So Kubeflow allows you all to deploy your own custom notebook. So we have something called notebook controller in Kubernetes. So the notebook controller is responsible on deploying these notebooks. For an example, the moment we apply a config for notebook, the notebook controller would wait for it, and it will start provisioning the resources that are required. So these are some of the examples of what we have in Kubernetes. So these are some of the examples for operators and controllers. So now let's have a look at the architecture, right? So in terms of the architecture, you can see that this is how the basic architecture of Kubernetes looks like, right? So now you can see we have something called API server, which is the important point, right? One of the most important points, the API server. The API server is responsible on dealing with all of this stuff. For an example, if I take a controller, the API server interacts with the controller and does the purpose of provisioning these resources. And then usually the API service is interacting with any of these resources. For example, if it's a deployment, if it's a deployment or interaction, the API server works with all of these resources and it does the resource adjustments within the cluster itself. And then we have something called nodes. So I already mentioned all the concept of node, right? So basically, nodes can be known as a worker. Also, a node would work as a virtual machine, an entire virtual machine with a dedicated resource allocation, right? So for an example, let's say if you have less resources for a particular purpose, it will keep adding nodes, right? And that's called the scaling purpose, basically. So for an example, if you have set auto scaling on Kubernetes, it will keep adding these nodes and it will keep adding pods, and the scaling would automatically happen whenever the resources are being allocated. Right? So basically, the automatic scaling and all of this stuff are handled through the API server, because these are automatic. These stuff are communicating with the API server, and from the API server, the resource allocation has been done. And then we have something called controller manager. So in controller manager, is responsible on dealing with all of these controllers that we mentioned earlier, and it will interact with the API server and this whatever the resource allocation. And for an example, let's say if you're installing any kind of controllers, if you're removing any kind of controllers, the controller management is fully done through the controller manager CRT. And then we have something called HCD. So HCD can be known as as a database, basically like a key value pair database, which stores all the configurations of Kubernetes. So that could be configs, so that could be any kind of applications, right? So HCD database, basically it's a stores persistent storage that stores all the configs of Kubernetes. And then we have something called kubelet. So kubelet is responsible on dealing with the API server to handle the operations of each node. So for an example, how to manage the pods, how to scale the pods, right? So all of these configuration within the node is done through the kubelet. And then we have the proxy and the scheduler, right? So basically both of the proxy and the schedulers are working to schedule these pods. For an example, let's say, like I mentioned earlier, if there's in scaling up and down, right? Scheduler and the kube proxy is working together to scale these resources and to scale down these resources and to manage the resource allocations that we're having. So that's the main responsibility of kube proxy and the schedulers. And you can see this is the basic architecture. We have the nodes and kubelet for each node, and we have the proxy for each node as well. And this is the HCD database, which stores all the configurations and also the API server, right? This is the basic architecture that we have in Kubernetes. Right, so now let's discuss more about the architecture that we are having in Kubeflow as well. So if you have a look at this architecture diagram, you can see that we have Kubeflow installation right here. And then we have several pods. So for an example, let's say in Kubeflow, we have different types of resources. We have notebooks, we have training jobs, we have different types of parameter tuning jobs, right? So all of these stuff are there. So all of these resources are being declared as pods here. So for an example, let's say we have one pod to pre-process, another pod to train, another one to handle all of these operations, right? So you can see these are different types of pods that are dedicated towards a particular purpose. And then you can see on top of Kubernetes, we can link GPUs also, right? So if it's a dedicated hardware, if it's a dedicated hardware cluster, we can link GPUs. For an example, if it's a complex machine learning workload such as image processing or any kind of a GAN model, that would require some kind of a GPU, right? So this GPU can be linked as a hardware resources towards these nodes if it's already provisioned in your cloud instance. So these GPUs can be linked as well, right? So very easily. We can link all of these GPUs to hardware resources with the nodes or the pods we have defined over here. And we have something called container registry. So like I mentioned, all of these resources are being deployed as containers. So even if it's a notebook or even if it's a workload, all of this stuff are being deployed as a container. And there's an internal container registry that we have in Kubeflow. So usually this Kubeflow container registry is there on GCR as a public container registry. So GCR is basically the Google container registry. So basically from the Google container registry, these containers are provided. So if it's for a notebook deployment or a workload deployment, so all of these workloads are there in the GCR or the Google container registry that we have. And all of these are provided via that. Right. And then we have something called Kubeflow dashboard. So it's like a visual, it's like a visual builder that we can visualize the entire all the operations of Kubeflow, where we can provision these resources, where we can manage these resources. So all of these stuff are there in the Kubeflow dashboard. It's a GUI. So very easily we can manage any of these resources, which is there in Kubeflow dashboard. Right. Now, let's talk about the importance of having machine learning on Kubernetes. The first thing is that portability. So I think I mentioned earlier as well, for an example, if multiple people are working on a particular project, all the people should have the same environment, right? Especially when it comes to machine learning, managing these environments can be challenging. For example, we had to work with multiple libraries or dependencies and frameworks. So in that case, maintaining a particular version of these frameworks can be very challenging, especially for machine learning engineers. So in that case, we had to make sure that our code is portable. For an example, my code has to work on the second part, then the other developers. So in that case, that's why I mentioned that there's this concept called containers, containerization. So I'm containerizing my application with Docker, and the other person can easily get the same container and run it in their machine environment as well. So we have this portability in Kubeflow because this is more like a container orchestrated platform. It's running on Kubernetes. So in that case, our code will be 100% portable. And the second thing is that scalability. So like I mentioned, our code has to scale up and down depending on the traffic volume or depending on the traffic volume that we get. So it has to be scalable properly. And the third point is that microservices. So for an example, if you have multiple models that you deploy on cloud, right? So it has to interact between all of these models and give proper response. So at the end, it has to interact with all of these endpoints, all of these machine learning models, and give answer, right, of the response. So in that case, the microservices architecture would help you a lot to interact between multiple models and give the response that you want. If there's any additional, if there's um, if there's more models, if there's any additional services. So all of these stuff are provided. And finally, we have monitoring. So like I mentioned, if it's like a tuning job or if it's like a high parameter tuning or something like that, we should always keep monitoring at a machine learning model, right? Or the tuning process or the training process. So in that case, we have the monitoring capabilities under Kubeflow. So we can see how the models are doing in the visual builder. And based on that, we can keep working on the improvements as well. And also the automatic monitoring is also there. So by enabling that, it will help us a lot to improve our models and help us a lot to see how this stuff is performing on cloud environments. Right. So now let's talk about Kubeflow. So Kubeflow is introduced by Google, and it's open source.
Hi, sir. So before we start with this session, I mean Qflow, can we take few questions?
Sure, sure.
There are few questions in the chat. So we'll start with, is Qflow open source? Okay, we'll start with this one.
Yeah. So
Once
as
we
you can
build,
see in the
yeah, sorry. So once
yeah.
we build ML algorithm, should we Dockerize the application or directly deploy on Qflow? So should we take this later?
Right. Okay. So to answer the first question, yeah, as you can see in the screen, it's open source and it's platform independent also. And second question, once we build ML algorithm, should we Dockerize the application directly deploy on Kubeflow? So all of these operations are possible. You can either Dockerize the application and deploy on Kubeflow, or you can directly upload your code to deploy and then Dockerize it. Because at the end, Kubeflow will containerize your application and run on their cloud servers. So in that case, both of these operations supported. Either we can Dockerize the application and run it, or we can directly apply our code on top of the notebooks that Kubeflow provides. So both of these operations are supported anyway on Kubeflow.
Okay. So this is related to the slides when you had containers in K8s. Is it necessary to create a VM to run the containers in K8s?
Right. So it's like this. So I'll be going to that point later on at the practical session that I'll be doing. So basically, we have multiple modes of deploying the Kubeflow platform on cloud servers. We can either deploy that as a VM, or we can deploy that as a Kubernetes engine. So both of these are supported. So I'll be covering that in the practical session that we'll be having in few minutes.
Understood. So one last question will take. Can we
Yeah.
create or use this kind of architecture or technology on premise? So this was probably 3 slides before when you had that
Yes.
architecture diagrams.
Definitely. So, like I mentioned, Kubeflow is Kubernetes is basically a platform independent. Even so, Kubernetes is platform independent. We can even deploy this stuff on on-prem servers, or we can use frameworks such as Anthos to link with Google Cloud to work. And so since Kubeflow is built on top of Kubernetes, we can easily deploy the framework on even on-prem servers as well. So if you want to link between GCP, we can use a framework such as Anthos to link between the GCP and the on-prem server also. So all of these operations are supported.
Thanks, Suresh, for answering. I guess we can continue now.
Right. Okay. So now, like I mentioned, Kubeflow is an open source platform developed from Google. And also, like I mentioned earlier as well, it gives you the features to tune and train and serving of models, and it does the automated automation as well. So these stuff are supported with Kubeflow. Anyway, we'll see that in action in a few minutes. So right. So now, if I talk about the stuff we have in Kubeflow, the architecture and the components we have in Kubeflow, we have something called Kubeflow notebooks, right? So we have something called notebooks. So there are some common notebooks that it supports. We have JupyterLab, we have RStudio, and also it supports Visual Studio Code as well, the online version. And then we have model. There are different types of frameworks that are supported for model training. TensorFlow, PyTorch, and all of these stuff are supported for model training as well. And then we have something called catlib, right? So we know sometimes we require to do the high parameter tuning. So in that case, the framework which is being used in Kubeflow is called catlib. So it supports all of these high parameter tuning jobs. And then we have something called Argo, which supports pipeline automation. And we'll talk about another framework as well. And then to serve the model, we have something called cave serving. So for an example, let's say if you want to, after deployment of the server, if you want to expose your model as a REST API, we can use the cave serving, the model serving framework to work as the RESTful API, and we can directly access the the endpoint of the RESTful API by calling the endpoint that it defines from Kubeflow platform. And then all of these frameworks are being used in Kubeflow, Istio, the service mesh, and Prometheus and Grafana for monitoring purposes. And then Kubernetes and OpenShift for managing the operators and the key framework. And also it's using all of these hardware resources depending on the availability of GPU, TPU. It uses CPU, GPU, and TPU. Depending on the resources that you all have, it uses all of these hardware resources. And like I mentioned, it's platform independent. You can deploy on AWS or Azure or GCP, or even it supports any of your on-prem servers also. Also, you can deploy Kubeflow instance on your local machine as well with something like Minikube. Right. Are there any questions before we move forward? Any other questions?
Yeah, there is one question which has been added. Can we try out a demo Kubeflow deployment without subscribing to any cloud service?
Definitely, yes. So, like I mentioned, we can deploy the we can deploy Minikube instance. So there's something called Minikube. So if you want to set up a local Kubernetes cluster in your machine, in your local machine, there's a platform called Minikube. So on top of Minikube, we can deploy the Kubeflow platform. So like I mentioned, it's platform independent. It doesn't matter. It doesn't require any kind of cloud service subscription. So you can even deploy that in a local machine as well by using something like Minikube. On top of that, you can deploy Kubeflow.
Understood. So yeah, those were the question as of now.
Right. All right. So now let's talk about what are the different types of ML technologies we have, ML tools we have. So Kubeflow supports all of these frameworks such as PyTorch, Scikit-learn, TensorFlow, XGBoost, right? So not limiting into this, it supports any of your custom environments as well. So just a matter of configuring the Kubeflow environment to match your training job. So it supports all of these frameworks and it supports your very custom environments as well, because since it provides you a container, you can configure whatever the environment you want and you can use it. So with the default configuration of Kubeflow, it comes with all of these frameworks. So yeah, so you can directly use all of this stuff without doing additional configuration. And then we have different operators. So I mentioned what are these Kubernetes operators are. So these are the operators that we have in Kubeflow. For an example, the moment we apply a particular configuration, these operators get triggered and it will provision the required resources, required hardware resources, and it will start processing the data. So for an example, we have something called Jupyter Notebook operator, an NumPy operator, MXNet, PyTorch, TensorFlow job, right? So all of these operators are there for different types of purposes. And whenever the configurations are applied, it will trigger the particular operator and it will start the whatever the process. And then we have controllers for maintain the Kubernetes, the Kubeflow UI also. So it has a visual interface that we can see all the pipelines and where we can provision any of these where we can provision any of these resources. So it provides you this UI also. And for serving also, we have something called cave serving. Like I mentioned, if you want to expose your model as a endpoint, we can use a cave serving operator, and we can easily serve our model as a RESTful endpoint. So all of this stuff can be done within the same platform, and the scaling, you don't have to worry about the scaling or anything. Within the same platform, you can. So it's more like deploying the Vertex AI platform on your own dedicated server, right? So Vertex AI is managed, and with Kubeflow, you can basically deploy this in any of your cloud provider, even on-prem. So it supports something like this. And then for model serving, we have PyTorch serving as well and TensorFlow serving. So all of these stuff are there. And for monitoring purposes, we have Prometheus and Spark. So these stuff are there for monitoring purposes. Right. So now let me quickly go through the experimental phase or the production phase, right? So usually we know when it comes to experimental phases, we are supposed to identify the problem and analyze data, and it goes until the tuning jobs, right? So basically, the entire process can be automated with Kubeflow as well. In the production phase, we have to, depending on the findings we have done in the experimental phase, you are supposed to transform the data and train the models and reserving, right? So all of this stuff has to be done. So like I mentioned earlier, the entire flow can be automated. So let's have a look at what are the different types of libraries and technical tools we have in Cube for these phases. Right. So for experimental phase, to develop this stuff, we have PyTorch, Scikit-learn, TensorFlow, and XGBoost. So these stuff are being provided by default from Kubeflow. And to experiment with development and training, we have different types of notebooks: Jupyter Notebook, and RStudio, and Visual Studio online version. So all of this stuff are there. To train the hyperparameter, we have a library called Catlib. So with Catlib, we can schedule these hyperparameter tuning jobs, and we can automate the process of finding the perfect recipe of a machine learning model. So that can be automated with Catlib framework also. And then to do additional training, we have TensorFlow jobs and MPy and PyTorch. So these stuff are there. So at the end, to monitor all this stuff, we have the TensorBoard also. TensorBoard also pre-installed. So in a cloud environment, we can visualize the entire machine learning models. We can see how the models are performing, and we can see the outputs of the models as a TensorBoard. So it's pre-installed along with the Kubeflow, the distribution. Right. So now let's talk about the main components of Kubeflow. So we have something called central dashboard. So the moment we launch a Kubeflow instance, this is what we get, the central dashboard. So central dashboard, I'll quickly show you the UI. This is how the central dashboard looks like. So now with the latest version of Kubeflow, this is different. This is the outdated version actually. So in the latest version, it's a different dashboard. I'll show you that very shortly. And here you can see what are the pipelines you have configured and also see the summary of all our deployments. And in the sidebar, you can configure notebooks, TensorBoards, models, volumes, any kind of automobile experiments or pipelines, and all of these stuff are visible in terms of the dashboard. So then we have something called notebooks. So I think I'm sure that all of you are familiar with different types of notebooks. I'm sure that 90% of the audience might have worked with something like Google Colab, right? Especially if you are a machine learning developer, I think all of you might have worked with Google Colab. But there are dedicated notebooks that you can configure on top of Cube. For an example, you can give a dedicated CPU resource, dedicated memory, dedicated hardware, dedicated GPUs, right? So depending on your hardware resource availability, you can configure these notebooks with dedicated hardware, right? So also you can set a custom environment also. For an example, you can see in the base image, we have Jupyter, and we have other stuff also, RStudio and Visual Studio Code as well. And under Jupyter, PyTorch, SciPy, TensorFlow, and PyTorch CUDA, and all of these frameworks are supported. And in terms of RStudio, we have Tidyverse, right? So all of these frameworks are supported in terms of different image types of Kubeflow notebooks. So we can actually configure, we can customize the environment, we can easily customize whatever the image type that we are having. So I'll show that in the demonstration also. Right. So now, why are we supposed to use Kubeflow notebooks, right? While we have something like Google Colab. So if we have a shared environment, the resources might not be sufficient for our training purpose. Sometimes we resources might run out. So in that case, the requirement for dedicated hardware is really important, especially if you have worked with the free version of Google Colab. There are limitations, right? Sometimes the resource might not be enough, especially for the hard. I think there's a size storage limitation also. So with all of these limitations, there are certain issues that we can have. But with using a dedicated notebook, we can eliminate all of these resources by defining the dedicated hardware resource that we want, and it will work inside our Kubernetes cluster. And that's the most importance of having a dedicated notebook. And also, for an example, let's say if your infrastructure is shared, you can actually define role-based access control also. For an example, you can give role-based access to different applications or services within your organization. So RBAC is supported. And also, we have something called pipeline creation in notebooks. So this is something new we have in Kubeflow. For an example, let's say if you want to visualize the entire machine learning model, the training process, there's something called pipeline creation. So we can visualize the entire thing and we can see how the training process is being done. So all of this stuff are there. So to talk about the environment that are supported, we have Jupyter Lab and RStudio and VS Code online version. And also, since it's a dedicated machine, any of the IDs can be configured by applying additional configuration. Just a matter of configuring our instance depending on our requirement. So by default, these stuff are there: Jupyter Lab, RStudio, and VS Code. Right. So now, this is something very interesting that I found in terms of Kubeflow. So we have something called Kubeflow pipeline. So you can call it a KFP, right? So in KFP, basically it works as a visualized environment that we can see how the training process is being done. For an example, let's say if it's a training job, we can see the different stages. For an example, pre-process, training model, testing model. So this entire pipeline can be automated. So for an example, if you have a notebook, if you have a uh, working IPython notebook, it automatically analyzes what are the most important components we have in the machine learning training process, and it will automatically process this pipeline. Right. So there's a framework that we are using to do this. So I'll go to that point as well. So we have a framework called Kale, right? So we can call it as Kubeflow Automated Pipeline Engine. So it's basically, for an example, you can see we have a notebook here. So in the notebook, you can see there are different phases: importing phase, and the NumPy model initializing phase, and transposing phase, right? So here you can see, by applying Kale on top of that, it will automatically create the pipeline. Depending on the structure of your notebook, it will automatically create the pipeline. So Kale is a really good framework that comes with Kubeflow. So that automates, that visualize your local notebook, and it will give you the diagrams and visualizing environment that we can see each step, and it helps us a lot to see how a machine learning model is doing. If there's an errors, we can easily visualize, and each step by step we can see how these stuff are being done. So it's pretty good, pretty interesting framework that I found on Kubeflow. Right. So now we have another framework called Catlib. So Catlib is a framework for hyperparameter tuning jobs. For those who are new to hyperparameter tuning, I'll quickly explain you all what hyperparameter tuning is basically. So hyperparameter tuning is like finding the perfect recipe for a training of a computer program. For example, such as machine learning model. So just like when we cook, you adjust the ingredients like salt, spices to make it delicious, right? So in hyperparameter tuning, we find the best setting for a machine learning model, and we keep adjusting the parameters until we get a specific response. For an example, let's say if you are tuning the model until we get a specific accuracy level, we keep adjusting these parameters. So the process can be automated with this framework called Catlib. And then we have these training operators. For an example, we have the chain operator, PyTorch operator, TensorFlow job, right? So all of these operators are there that automates the training process. So these comes with the pre-installed version of Kubeflow. And most importantly, it supports multi-tenancy. For an example, like I mentioned earlier, since it's built on top of Kubernetes, it does role-based access control, or we can call it as RBAC. So with that, it handles different types of user policies, and different types of applications could interact with your APIs, and we can easily configure these access roles and different types of user permissions levels. So all of this stuff are there in terms of multi-tenancy. So this is a very basic example that they have given in the default documentation. As you can see, there are multiple user roles: profile Alice, profile Bob, and profile team. So you can see how the permissions are being given to access specific resources in terms of Kubeflow, right? You can see edit access has been given for a particular user, and also you can isolate these user roles, and you can give access of specific resources that we define for the resources in terms of Kubeflow. Right. So now let's get into the practical part, right? Installing Kubeflow. So there are different ways of installing Kubeflow in different cloud providers. So if you go to the documentation, right. So in the official documentation, you can see it has provided different ways of installing on different types of cloud providers. For AWS, they have different types of resource allocated. You can see it has the benefits that we can apply to install these resources. And for Azure, also it supports GCP and IBM Cloud, and any of these cloud providers is supported to install Kubeflow. And also, like I mentioned, we can set up Kubeflow in local environments also with Minikube or any kind of other Kubernetes operator or any kind of Kubernetes provider. So installing in local machines are also supported. So these are the cloud environments that supports from Kubeflow. Right. So now let me get started. So I'm going to go to GCP documentation. Right. So before that, let me quickly explain you all what we are going to do today. Right. So we are not going to use a GK instance, or we are not going to use a Google Kubernetes engine because it takes a long time to deploy, and we are going to use something called minikf, right? So something similar to minikube. It's something similar to minikube. So it uses a minikube instance to deploy as a single node application. So in GCP, they have given something called minikf. So with minikf, we can deploy the entire service of Kubeflow as a single node application on top of Kubernetes. So we'll be using minikf to deploy this instance. And alternatively, we have GKE, like I mentioned, Google Kubernetes Engine. We can use that to deploy our application as well. But since it takes time and since it's complex to understand for a beginner, I'm not going to do the GKE steps. But if you're interested, you can refer to this documentation, and it has all the guidelines on how to deploy the instance on GCP, the GK instance. So all of these guidelines are given in the official documentation. So you can see setting up the GC project or client, deploying the management cluster. So under these stuff, you can find how to install, how to set up this GK cluster on top of Google Cloud Platform. But I'm not going to do it today. Instead of that, I'm going to use this service called minikf to deploy our deploy a Kubeflow instance. Right. So now I hope you all can see this slide. So I'm going to do a code lab today. Very basic, very briefly. I'm going to do this code lab today. So you all can access this link. You can go to this link. So it's a code lab that Google has provided.
Can you share that with me so that I can send it to everyone?
Yeah, sure. I'll do that.
I got it. Thanks. We can continue.
Sure. Right. So so from this code lab, it covers you the basics of configuring the environment and to configuring a very basic tutorial. So anyway,
Suresh, 1 minute, 1 minute. So there is a question before we start.
sure.
What do you mean by single node application in Minikube? Couldn't follow properly.
Right. So before that, I'll quickly explain what's Minikube is basically. So usually, the main purpose of Kubernetes is to handle scaling and to handle the deployments automatically. So basically, Minikube is an application that you can use to try out these Kubernetes in your local machines and also in test servers without configuring a scalable environment. So with Minikube, it's more like a single node deployment, single node as in single worker node, right? So with single compute engine instance, we can deploy a Kubernetes instance there to work with Kubernetes operations. So basically, it's more like a test server kind of thing that we can have without focusing much on the scaling aspect. It's more like a test server kind of thing, basically. It provisions you a Kubernetes environment, but as a test environment mostly. I hope I answered the question properly.
Yeah, we don't have follow for that, but I guess we can continue. We have two
Right.
questions, but probably I feel we can take that in the end.
Yeah. All right. So now let's see how to deploy this instance first of all. So I'm going to my Google Cloud project. So I already have provision project over here. So I'm going to leave it over here. So I can go to the marketplace of Google. So basically, they have a marketplace where we can do these deployments automatically, and there are different types of deployments that is about from the GCP marketplace. So if you search for minikf, you can actually find this minikf platform over here. Click on launch. Once you launch for once you launch for it, you will have to set up the environment, right? So you'll have to set up the environment. So you can give your name for the deployment, and you can set up your region here, right? So you can set up a region somewhere like this, and you can set up the machine specification. So you can see N1 series, I'm having N1 series machine, and my machine is going to have some around 8 vCPUs, 4 cores, and 30 GB of RAM. So right now I'm in the free trial version, so it's going to cost me somewhere around 355 USD per month, but you can choose a lower spec as well depending on your requirement. So since I'm on the free trial, I'm going to choose this one. And for the boot disk, it requires somewhere around 200 GB as a minimum requirement. And if you get something like this, if you get error something like this, it says you have gone vCPU total 8 CPUs. We can choose a lower spec as well. And also for the hardware, for the hard disk specification, we can choose standard disk basically. Without choosing the SSD, we can go for a standard disk if you get that error. And also if you get that error also, so right now my quota is exceeded. That's why I'm getting this error saying quota exceeded. So I can go for a lower CPU count, or I can request additional quotas in my quotas page. So right now my quota is exceeded. That's why I'm getting this error. But anyway, I already have deployed an a minikube instance, so a minikf instance. So I'm going to use that during my tutorial. So anyway, once you click on deploy, it will provision the environment for you, and at the end it will give you the base, the access URL or the endpoint, and it will give you the username and the password as well to access whatever the UI dashboard. So at the end it will give the endpoint and the username and the password as well. So by using the credentials, you can log in to the visual interface of Kubeflow. So assuming that I have deployed the platform, I'm not going to do it at the moment. I'm going to use my pre-deployed version. I'm going to compute engine now. Right. So you can see I have deployed 2 instances. I'm going to this one, my latest deployment. So you can see this is my predefined instance. Right. So now I'm going to access my dashboard. Right. So like I mentioned, after the successful deployment, they will automatically give you the endpoint and the username and the password of the dashboard also. So you can just simply visit that URL and you can simply access this dashboard, the visual dashboard from the configuration they have given. And now, if you want to start the configuration, you have to SSH into the machine, into the virtual machine. So I'm going to click on this and I'm going to choose SSH. So in the first boot, you have to, first of all, SSH into the machine, and you have to run the minikf command, and it will take you through the setting up process, and it will take about half an hour to provision the entire interface. So I'm going to do it at the moment. Let's see. I'll quickly show you how it should be done. Right. So you can see it says welcome to minikf. Type minikf to ensure everything is up and running. So I'm going to enter this command quickly. So it says, you can see it gives me the endpoint and my username and the password as well. So with these credentials, I can log into my minikf environment, right? So I can quickly use this endpoint and the username and the password to log into my instance. Right. So now I'm going to skip that process because I have already configured the environment. So if it's your first time, it will take about half an hour to provision the entire thing, and it will ask you some configuration questions. So with that, you can provision the environment for your specific requirement. Right. So now, once you log in, this is the interface that you will see. So you can see it has improved UI compared to the one I shared earlier in the slide deck. So here you can see all the stuff and some summaries and the notebooks and tensor boards and all of these configurations are there. So now what I'm going to do is I'm going to configure notebook. So I had to go to notebooks and click on new notebook, right? So from here, you can choose either JupyterLab or VS Code or RStudio. So any of these notebooks can be chosen. So I can give a particular naming convention also. and then I can choose the CPU requirement and the memory requirement as well. So I can give somewhere around 5 GB, and number of vCPUs are 2, and 5 GB of RAM. So if you have GPUs, you can choose that also. And then from the volumes, you have to set up the volume levels here, basically the space allocation for the instance. So for the data volume, you can click on new volume. And from here, you can choose the amount of GB that you wanted to be. So for an example, in this case, I'm entering somewhere around 10 GB to store my data, to store my data sets, and to store my development environment. So somewhere around 10 GB I'm entering here. And then once the entire configuration is done, you can click on launch. So since I have already done this setup, I'm not going to launch it at the moment, but these are the configurations. Give it a name. Give it a name, choose the environment, and choose a number of CPUs and memory, and the workspace volume, and then the data volume, right? So all of this configuration has to be done. And then we have to, yeah, so that's a configuration. And once you're done with it, you will see something like this. Once you're done with the deployment, it will come into this. So you can click on connect. So it will take you to the connection. It will load the Jupyter Lab, the development environment for you. Right. So now you can see it has loaded my development environment. Like you can see, it's a Jupyter Lab environment I have configured. So it's hosted in my own clusters. You can see it's my own dedicated environment. So now what I'm going to do is I'm going to clone the example they have given in this code lab. So now I have done this setup. All right, this part is also completed. So now I'm going to clone the example they have given. So now I have provisioned my notebook server also. And then what I'm going to do is, yeah, so I'm going to create a new directory. So I'll create a new folder called workshop. I'm going to change my directory into workshop, and then cloning whatever the data they have given, the repository they have given. Right. Changing the directory to KL. And yeah, so if I go to this, my folder is there. I'm going to the examples and dog breed classification model. So basically, this is more like a very basic CNN, and so it uses 3 models basically: CNN model, and it uses ResNet 50, and it also uses VGG model to classify these dog breeds. So it uses 3 models basically as a comparative example. So you can open the V2. So V2 version has the latest version of the libraries and dependencies. So I'm going to open it, and then I can run the dependencies. So I can click on this to run the requirement installation. Yeah, so you can see all the dependencies are already there. So I'm going to run the import section first of all to make sure that everything is set up properly. Right. So now you can see there's no other errors except the queued error, because right now I don't have any GPUs. That's why I am getting this warning call. There's no GPU found. So it's fine. I can ignore this warning. To make sure that the TensorFlow version is there, you can see I'm using TensorFlow 2.3.0, and there's no GPUs also. That's fine. So I can just simply demonstrate what I have here. So now going through the code, let's see what we have got here. So we have different stages. We have the processing stage. So under the processing stage, you can see we have the train set generator, and different generators are here. And then we have the detection phase. right? So it's using this pre-trained ImageNet model with ResNet 50. So I'm sure that most of you are familiar with ResNet 50, which is a pre-trained model architecture. So it's a image processing model architecture, and it's using this ImageNet pre-trained model to predict the dog images, and it's training with this model images that you're passing. Right. So this is ResNet 50, and the second step is basically they're using a custom CNN also. So it's using 3 models just to do the comparison of each model and see the accuracy levels. So this is a custom CNN model. You can see it's using to train these dog images. Right, an evaluation step. So you can actually go through the entire thing. I'm not going to go into depth of the machine learning task they have done, because we are mostly going to focus on the pipelines and the Kubeflow operations. So I'm not going to discuss in depth on what they have done here. So in summary, what they have done is basically they have used 3 models, ResNet 50 and VGG, and they have custom CNN to make sure that to evaluate these models and to see what gives you the best output. So depending on that, so basically that's what the summary of what we are doing here. And then I mentioned that we have something called Kale, a very interesting framework that we have in Kubeflow. It's called Kale. Right. So you can see Kale is a pretty good framework. What it does is basically it will analyze your workbook notebook, and it will create pipelines out of it. For example, if there's in different stages of processing or information, processing or data, it will automatically create a pipeline out of it, and it can be used to visualize your entire machine learning pipeline in an interactive manner. So we'll see how that has been done. Right. So now what I'm going to do is I'm going to create a pipeline with the Kale framework. Right. So I'm going to click on this section, and I'm going to enable the deployment panel now. So from the new experiment, I can click on this new experiment, and I'll give it a name, dog experiment. So I'll give a name, pipeline name, same thing. And then I can configure these advanced configurations, use these notebooks volumes, right? Take rock snapshots during each step. So these configurations has to be enabled. So compile and run. So you can see now it's validated in my notebook, and it takes a snapshot of it, and it will automatically analyze what are the important parts and what are the steps that are involved. So you can actually customize this automation process also. For an example, if there are specific requirements, if you want specific visualizing approaches, you can give custom levels of visualizing. So that can be done with the KL SDK they have given. So the KL SDK is there for Python also. So you can directly use it, and you can customize it depending on your requirement also. So right now, by default, they will automatically go through your code base, and it will analyze whatever the important factors, and it will summarize based on that. Yeah. So now you can see validation has been done, taking a snapshot, compiling notebook. Right? So now if you go to the view section of the pipeline, you can see that it creates a volume. So now you can see the first step has been completed. Now it's processing the data, right? So for an example, if I go back to the data set, if I go back to my workbook, you can see it's right now it's executing the data processing stage, right? So this part, it starts this stage. You can see it says step data processing. So now you can see it's doing this particular part right at the moment. If I refresh that, yeah, so you can see if you go to this logs, you can see what kind of processing they are doing. Yeah, so it says pending execution. So at the moment, I think there are some other experiments are also running. So let me show you that. So until those are being completed, it won't start. So I'll go back to my previous example, my previous runs, and I'll show you how it looks like. So yeah, so once this particular step is completed, you can see you can actually view the logs also, right? So you can see how the processing is being done, and you will see all the logs under this section, and also you can visualize this stuff also in the metrics. And in the logs you can see all these processing logs has been are there, and you can see the different steps of training are there. So after training, you can have the evaluation stage also. So in the evaluation stage, you can compare all of these models to each other, and you can have the different types of accuracy levels, and you can do the comparison to each other, and you can decide that part. So until you can see up to this point, the model has been completed. So it will take some time to process. So right now I don't have any GPUs, so it takes some time to process these models. So that's why it's in the pending state at the moment. Right. So before I move forward, any questions we have got?
Yeah, I'll add two questions in the screen.
Sure.
Can we deploy models as endpoints using it and use them as API?
Yes, definitely. So, like I mentioned, we have something called Cave Serve in Kubeflow. Cave Serve is being used to serve these models as RESTful endpoints. So, for an example, after the training process, it will appear under the model section of your Kubeflow dashboard. After training process, something similar to what we have in Vertex AI models, right? So it will appear under here. So you can easily deploy that as an endpoint. So we are using this framework called Cave Serve. Uh, there's something called Cave Serve that we're using to serve these models as base endpoints. K serve, right? So you can see we can easily serve a model as RESTful APIs. And there are some other tools also. There's a tool called Bento ML, and there's another one called ML. There's another one called ML Run. So we can use any of these frameworks to easily serve a model as a RESTful endpoint. And I'll share this link also, so you can go through this link and you can have understanding on how we can serve this model as a RESTful endpoint to make RESTful calls and get the results. So yeah, can do that as well. So once the training is done, it will appear under the model service. So here you can see all the models are appearing here. So under that, you can easily deploy that as a function. So usually it works as a cloud function. So like a one-time function call, and it gives you the response from your model itself. So it will work as a function basically. So these examples are given. So you can go through it and you can have understanding on how these functions are working. So yeah, any questions?
Yeah, we
Any other
have
questions?
one more. What is difference between Kubeflow versus MLflow?
Keyflow versus?
MLflow.
All right. So MLflow, we can actually compare MLflow and Kubeflow together. MLflow is actually a framework. It's like a library to serve your machine learning models as endpoints. So Kubeflow is a platform, and MLflow is a library, just a library to serve your machine learning models as RESTful endpoints. Basically, we are giving the definition of how we are supposed to access the data of the machine learning model, right? So yeah, so that's the thing.
Got it. So one question I have from my end. So usually, right, when we are building these ML algorithms, I saw your slides that were related to Katib. So Katib mainly, is it used for hyperparameter tuning, or what exactly is it used for?
Yes. So basically, Catlab is used for hyperparameter tuning jobs to analyze the different parameters we have in the machine learning model. I'll go to that point as well because we have another very brief example to demonstrate on how to do a basic hyperparameter tuning job. So I'll go to that point also. So give me like few minutes. I'll quickly go to that point as well. I'll answer that question at that phase. But small concern. I think the earlier question, did you refer to ML flow or did you actually refer to ML flow? Did you refer to ML run? Can I get a small clarification because ML flow
It's
is basically
MLflow.
Gen AI. All right. So basically, it's a Gen AI based platform. It's a managed platform. So like I mentioned, the main difference between Kubeflow and ML flow and other platforms is that It's MLflow works as a managed platform, and Kubeflow is more like a bare metal platform that you can deploy any kind of cloud provider. But MLflow is more towards Gen AI. So it's a different platform. It's a managed platform, so that's the main difference basically.
Understood. So I guess we can proceed. So the code demo is done, yeah, or is there any code lab still?
Yes. Yeah. So now, since we have done the pipeline, we have done up to the pipeline part. I'll quickly go to the parameter tuning part as well. Right. So if you go to the tutorial, the code lab. Yeah. So at the end, this is how your pipeline is going to be after the completion of the training process. This is how your pipeline would look like. The train models and the statuses and the final snapshot also. Basically, the outputs of final models will be stored as snapshots, and this is how the interface is going to look like. And then if you go to the section number 5, transfer learning with hyperparameter tuning. So since we have a CNN also, I'm going to be doing a very basic hyperparameter tuning job. I'm going to schedule a very basic hyperparameter tuning job along with the configuration we have already in our platform. So now if I go to this section, right. So if I go to this section, you can see it, there's some under the, yeah. So under the pipeline metadata, you can see there's something called hyperparameter tuning with catlib. So actually, they have given two examples. We have the I'm opening the V2, but if you want to demonstrate the hyperparameter tuning job, if you go to the V1, you can actually see what are the parameters they're offering. Right? So for an example, you can see the nodes number and the learning rate. So all of these stuff can be configured, and the epoch count and all of these stuff can be configured. So from here, you can enable for a hyperparameter tuning job, and you can configure the node ranges and also the minimum range and the maximum range. And also the most importantly, not these are not the most important stuff. So for an example, the important stuff is going to be the accuracy, right? So here you can see test accuracy level. ResNet 50, I'm accepting for a accuracy level of 90%. So I can define that over here, and I can define whatever the trial counts and the maximum trial counts and fail counts, right? So all of these configurations can be given as inputs, and you can see the reference metric has been automatically extracted from the catlib module, and you can give that also. So right now I am waiting for a goal of 90% of accuracy. So I can define my goal over here, and then once I'm done with the configuration, I can close this and I can run the catlib job. So now you can see it's provisioning the catlib job, and it's taking the snapshots. And yeah, so now you can see it says running catlib experiment. So I don't think at the moment the experiment will become successful because it requires GPUs to do this training. So right now I don't have any GPUs attached to my notebook, so I don't think the experiment will become successful because it takes a long time to train with the CPU. So I don't think I think it will take a long time. So by the way, you can see the process of the tuning job by going to this section. Yeah, so you can see the experiment is running at the moment. And you can see the status of it as well. It says status created, and it will keep running multiple times until you get that particular accuracy level. It will keep running the application. You can see this is my goal, right? You can see test accuracy level has to be over 90%. So once I reach that goal, it will it will terminate the process, and yeah, so it will keep running until I get that particular accuracy level. So that's the main goal of this training process, and yeah, I think that's it for the demo. But few things I had to mention that if you want to monitor all this stuff, we have tensor boards also. Once you have the model deployed, we can visualize the process with the tensor board, and we can configure tensor board from here from this section, and we can pass our parameters, and we can visualize it very easily. So all these things can be configured with the GUI, the visual interface that they have provided. So yeah, I think that's it for the code lab. Um, so you can see for an example, in the takes time, I'll show you the result of it. So you, for example, you can see once the model has reached the accuracy level that I wanted, it will give you this kind of output, and based on that, you can do the adjustments, and you can do the further processes once you get this particular result. Right. So that's it for my code lab, and I'm open for any questions.
Thanks for the demonstration. We'll wait for a few questions. We'll wait for 2 more minutes until we have few questions,
Sure.
and I'll let me check if we have missed any question.
Sure.
This was, I guess, this was already covered. Yeah. So what we can do is, until we have any questions, I'll ask a roadmap question from my end. Suppose if any data scientist wants to learn MLOps or Kubeflow, where should he start from? What will be its his beginning point?
Yeah. So I think okay. So MLOps and Kubeflow are like two different. Okay. So basically, especially when talking about Kubeflow, it requires some kind of prerequisite knowledge in terms of Kubernetes, because this is more linked to Kubernetes, and it's running on top of Kubernetes as well. So it's better if you can can have some fundamental knowledge of Kubernetes, and how what are these containers and pods, and the basics of some of the controllers. So I think it's best to learn the very basic fundamentals of Kubernetes. If someone is going to get prepared with MLOps, I think something similar to DevOps, the life cycle has to be learned. For example, it's not just a subject area that needs to be learned. Basically, it's like a culture that needs to be learned. MLOps, from it's like maintaining the same pipeline from the model data gathering part to the model serving process. So basically, it's more like culture that should be maintained, because uh, Kubeflow is just a framework. So if you want to learn Kubeflow, the documentations are there. If you go to the official documentation, all the stuff are well described. So from the installation process to the deployment process, well given. And also there's something called Aricto. So basically, Aricto is right now managing the Kubeflow platform. So they have something called Kubeflow Academy. So if you go to this section, if you go to the Aricto Academy, you can actually find out the lessons they have given in terms of exploring Kubeflow. Right? If someone wants to learn about Kubeflow, you can go to this Aricto Academy, and they have given some interesting lessons and tutorials on learning Kubeflow. So you can just go to it, and you can understand the basics from Kubeflow, Kubernetes to Kubeflow, right? So these lessons are there, so you can just explore it. They have given some practical courses, so you can just visit these sections, and you can learn about. They have given some interesting videos as well, so you can refer to these stuff. And there are slide decks, and there are learning resources. So from this, you can learn the basics of Kubeflow, and also with the documentation, they have given so many tutorials.
Great. Thank you for sharing this thought. And I guess we don't have any more follow-up question. Do you have any closing thought from your end?
Yeah. So, in my opinion, I have worked with a lot of developers so far, a lot of machine learning developers, researchers, students, and all. So, I think right now, I feel like most of them are not familiar with MLOps. There's a field called MLOps because this is being recently being discussed, and DevOps is coming up. DevOps was there for a while, but MLOps is new to most of the people. So I think this is something really important, and I think in the future also there will be so many career opportunities in terms of MLOps. So I think it's the high time to learn about MLOps, and it's high time to learn about the basics of MLOps and to improve your knowledge. And it will really help. It will be really helpful for you all to improve your career pathways in the future as well. So I think I would like to highly encourage everyone to study the concepts of MLOps and study the concept of maintaining the machine learning pipelines. So it will really help you all a lot in terms of career development. If you're trying to become a really good machine learning developer, I feel like that's something that I would like to address.
Okay. Thank you. Thank you for sharing your thoughts. And whoever are live, thank you for joining us live. And I hope you found this particular session very useful. Suresh covered various frameworks that can be integrated with Kubeflow, and each framework has its own specialty. Like Katib, which I'm familiar with, it has hyperparameter tuning. Just like that, there were a few more frameworks which were covered in this particular talk. And thank you again. Thank you, Suresh, for accepting the invitation and sharing your expertise on Kubeflow. It was really insightful and grateful.
Thank you for having me. Thank you very much.
Okay. Thank you again. We'll meet in next live session. Thank you.